Hello everyone, this is Oshani from Cheenta.com. I have with me two of the physics faculties from Cheenta, Tonumoy Banerjee and Panchajan De. We have been having a lot of fun with physics. Our new module is about to begin in all the three levels, level 1, level 2 and level 3. All the three levels we have new modules starting on the third week of March. Let me tell you a little bit more about the level 1 module. So Tonumoy, in the level 1 module, we will be working on motion in 2 dimensions, I understand. And we will go through projectile motion and a bit of circular motion maybe, but majorly using algodo experiments.
Yes, sir. And also we can take some interesting problems like riverboat problems, which are also in motion with 2 dimensions.
So yeah, I think the main idea is to solve problems and do experiments. These are the main two things we want to do. Only if a student is able to solve nice, interesting, non-routine problems, and if he is able to create experiments in a simulation or physically, we are still doing simulated experiments. Only then the student can achieve conceptual clarity. So level 1 is for students in grade 6, 7, 8 who are just starting out with physics. In the level 2, there is also a new module starting. It is also on motion in 2 dimensions. This is for students who are in class 9, 10 in the NSEP, the first level of Physics Olympiad standard. So maybe you don't know a lot of calculus. You've just heard about it. So Tonu, I think we are planning to start with a bit of introduction to trigonometry in there, right? We need trigonometry for this.
The basics of trigonometry is very important, and the basics of the vector components also. We will be starting with that also.
Excellent. So the plan that we have is to use beautiful problems from places like NSEP and also the Russian Physics Olympiads. We are translating problems from the Russian Physics Olympiad and using them in our classroom. So to use those problems, and using those problems, we want to understand trigonometry, we want to understand principles from vector algebra, and then go on to solve projectile motion, circular motion, and other related two-dimensional motions. So this can be a very interesting module for students who are in grade 8 to 12, at 8 to 10, or even in 11th and 12th. If you do not know much of calculus, this will be a nice place to start. This is level 2. That's also starting in the third week of March. Panchajan is conducting the research sessions at Cheenta, as well as the level 3 physics Olympiad program. Level 3 is for people who understand calculus, who know a little bit of calculus at least, who have a grasp on trigonometry and vector algebra and these preliminary mathematical tools. So I understand that, Panchajan, we are going to go into deep problems in mechanics.
We'll be doing some like international physics Olympiad level problems from mechanics. So do some problems in laws of motion, also in projectiles, and also conservation of energy.
That's excellent. Another very interesting thing that we are trying to do is to have the research training program attached with the Physics Olympiad program. So in that, Panchajan and the students from level 1, 2, and 3, they are working on existing experiments, trying to understand how to sort of replicate them and understand the data that's out there. You were saying something about how you are using Python to understand motion. Can you say a little bit more about that? What kind of paper you want to explain to the students? What kind of paper, what kind of experiment are we looking at in the training program?
So when we observe when we theoretically calculate the motion of a charged particle in a uniform magnetic field, we observe it's moving in a circle or a helical path depending on its velocity along the magnetic field's direction. We are trying to replicate that in our Python code. And also after that is done, we'll be doing for non-uniform magnetic field, because there we'll observe various different trajectories. And we are also planning to do the study of charged particle motion in Earth's magnetic field, assuming a model.
That is fantastic. So this is something that I like strongly believe, that physics needs to be, I mean, at least a part of physics needs to be done in a hands-on manner. Experimental physicists do that all the time. Of course, problem solving, theoretical physics is a big part of this entire story, and we also want to do this. We love solving problems, but to the kids who are joining or who are about to join or who have already joined the physics program at Cheenta, make sure to solve problems, to do experiments, and in the research training module, please read the papers and replicate the experiments that sir is helping you to do. Thank you, Tonumoy and Panchajarno, for joining us. We have another faculty, Kazi, who is not able to join today, but hopefully in the next meetup we will be able to see him. Thank you, everyone. Bye.